Let's take a look at these last two problems from the review. Implicit differentiation. Again, it's good. These are just two problems. You want to find other problems. Look in other books. Look in our book. Find other examples of implicit differentiation. It's for sure a skill that has to be on the fight in the midterm. Um, it's an important technique and process to know how to use. And so what you start to see again, many times there's confusion of like, how come there's y primes, right? Well, technically on these there's just chain rules. And so technically, I don't want you to, again, if you're thinking about things, when I take the derivative of this here, by just looking at the derivative of this, really what's happened is the derivative of x is 1, right? And that's where you just get the 1, right? Here, the derivative of this is derivative of x is 1. But when you really think about it, derivative of x is 1 times the dx, technically. It's like the chain rule times that. But that's just 1, the derivative of x. So that's where we don't write the x prime, or that's why the y prime comes up. We don't write x prime because the derivative of x with respect to itself is 1. So technically it is there. We always do this x prime and y prime, but x prime is always 1, right? The derivative of x with respect to x. So that's why we don't write it. So technically, if we're going to be technical, this is 1 times x prime plus, if we were going to be technical, right, times x times e to the power of y times the derivative of the exponent times y prime, right? It would look like that. But we don't write, that's an x prime. We don't write the x prime. It's just a 1. That's it, right? It's a 1, oh, sorry, times e to the y. I missed that part, but times e to the y. So let's do that again. So this would be derivative of x is 1 times its x prime times e to the y plus it would be x times e to the y times y prime. Now we don't write x prime because x prime is 1. X prime equals dx over dx. That's why we don't write it, but it's always there technically. So you're always going to have an x prime, y prime in these expressions as you do it. And so you can see you end up with this plus this equals this. Now where does this come from? I'm looking as I look at our work here. Did we do something here? So we have 1 e to the y plus x e to the y, y prime. Oh, I just forgot to write e to the y there. There's an e to the y there. Good. Equals this here, right? 1 times x prime, but x prime is 1, so it's just 1. Derivative of y is 1 times y prime, right? Again, this technically is 1 times x prime plus 1 times y prime, which gives you 1 minus, because x prime equals 1. It's the derivative of x with respect to x. But again, we don't write that. I just want to make sure again, because I'm going to get confused. How come when do I use y prime, x prime, that type of stuff? So there should be a y here. Perfect. And then as we finish, where does this stuff come from? I'm isolating the y prime, right? So we want to isolate y primes together. So you bring the 1 over and then you bring this over here. And so when you isolate those y primes expressions, you have that, and then you factor out those y primes. Always the factor. It's just there's a double negative here. We would end up with this here, and then you end up with this here. You're solving for the y prime. Again, I could have brought it the other way. We could have brought this to this side and then this over, and you would have 1 minus e to the y, which you end up. So that might have been easier to do, but again, it's your choice about how you do that. This one's a little bit more complex as you go and how this gets written. So make sure you follow along carefully. Again, the derivative of this, and then I need the derivative of the inside here. And that's what this is here, right? That's the derivative of xy is in here. And then this here, the derivative of 1 is 0, so it disappears, and you have that there. So in the end, again, after you have these expressions, you want to put the y primes together. Now, notice that this is a multiply, so I can't just move this over. I have to distribute the sine xy to both pieces. And so notice both pieces get the sign. And then now I move this over here, and then you can factor out the y primes. And then you can solve for that. So just keep that in mind. And let's do this last one, which is the definition of a limit. I'm not going to give you that full definition problem, but more from like a graphical perspective, being able to understand that definition. And so what we're looking for here is as x approaches 1, right? So what this turns out to be, find the given, use the given graph of fx to find the number delta such that the absolute value, such that if the absolute value x minus 1 is less than delta, then f of x minus 1 is less than 0.2. In this case, this is kind of like your epsilon on this case. Epsilon is 0.2. And so you're really trying to find out, right, as we get closer and closer to this, right, what happens to the function? What am I getting closer to? And what we're trying to find out is I want to get, as I get closer and closer to this here, I want to get, right, as we see what we have here, I want to be within 0.2 of that value, because f of x equals 1, it looks like right here. And so if f of x minus 1 is less than 0.2, then we have this, we can rewrite this, right? Then f of x is between 0.8 and 1.2. That's what's going on here, going back to our definitions for the limit. And then if this, you have the 0.8, if f of x is between 0.8 and 0.2, right, is true, this is true when what? When x is between 0.7 and 0.1. So that's what we're looking for. So when we're looking for the delta, we're always looking for the delta that's closest to it, right? That's all makes it true all the time to be within 0.2. And that's the key here, because if I go a little past 1.1, if I used, again, how far away am I? I'm 0.3 away. If I went to 1.3 over here, that this function is a lot further than 0.2 away. So that's why we're always using the minimum value, the minimum out of this here, out of that notation here. So keep that in mind, because it needs to be true. It needs to be, for what delta is it always within 0.2, and you always use the smaller one, the minimum of that. So the delta would be 0.1 in that case. Again, because it needs to be true always less than 0.2. And so if I go past, it's true over here, but it's not true on the, I can't go other 1.3, it's not true. So I wouldn't use 0.3 as my delta. It's true on one side, but not on the other side.